Competitive landscape, examination of the global response to the lab leak theory and its impact on biodefense strategies and biotech investments. Introduction. The global health landscape has undergone significant changes in the wake of the COVID-19 pandemic, particularly regarding the lab leak theory's credibility and its implications for biodefense strategies across nations. As various countries reassess their approaches to public health and security, the biotechnology sector is poised for a major shift in investment and innovation. This report examines how 10 countries are adjusting their biodefense strategies by 2024 in response to the lab leak theory and offers expert predictions on market shifts in biotech investments by 2026. The rise of the lab leak theory. Shift in intelligence assessments. Recent intelligence assessments from agencies like the CIA and FBI have brought renewed attention to the lab leak theory, suggesting a greater likelihood that COVID-19 originated from a laboratory rather than zoonotic transmission. Despite low confidence in these findings due to insufficient evidence, the shift represents a significant pivot in the narrative surrounding the pandemic's origins. The CIA's assessment indicates a departure from previous neutrality, suggesting that the research-related origin of the pandemic is a serious consideration, echoing sentiments shared by FBI Director Christopher Wray. Global reaction and controversy. Countries around the world have reacted differently to the lab leak theory. While some nations have called for transparency and accountability from China, others have taken a more cautious approach, emphasizing the need for further investigation before drawing conclusions. This uncertainty has led to a heated debate within the scientific community, with many experts arguing that there is no definitive evidence supporting the lab leak theory. The biotechnology patent landscape. Current trends in biotech patents. The biotechnology sector is characterized by a competitive landscape, with the United States leading in biotech patents 39% in 2020, followed by the European Union 18% and China 10%. A recent report revealed that over 96% of biotech patents pertain to industrial and medical applications, highlighting the importance of innovation in biodefense and public health. This competitive environment has significant implications for how countries are adjusting their strategies in response to the evolving understanding of bioweapons and accidental releases. Implications for biodefense strategies. Countries are beginning to realize the importance of enhancing their biodefense capabilities in light of the lab leak theory. This includes increasing research funding, improving laboratory safety protocols, and investing in biotechnology. Key areas of focus include: 1. Vaccine development. Countries are prioritizing the development of vaccines to ensure swift responses to future pandemics. 2. Pathogen surveillance. Enhanced surveillance systems are being established to monitor potential outbreaks and identify emerging pathogens. 3. Bioinformatics. Investment in bioinformatics is critical for analyzing data related to pathogens and improving response strategies. Country-specific adjustments to biodefense strategies. United States. The U.S. has ramped up funding for biodefense research, particularly in vaccine development and pathogen surveillance. The government is also emphasizing enhanced laboratory safety protocols to prevent future incidents. European Union. The EU is focusing on boosting biotechnology and biomanufacturing capabilities. Initiatives have been launched to enhance competitive standing in the biotech sector, including creating collaborative frameworks for research and development across member states. China. China has faced scrutiny over its laboratory safety practices. In response, the government is expected to increase transparency and collaborate internationally on biodefense and pathogen research to restore credibility. United Kingdom. The UK is investing in advanced manufacturing facilities for vaccine production and pathogen detection, with a focus on bioinformatics to improve public health responses. Australia. Australia is enhancing its biodefense strategies by investing in research partnerships with global biotech firms and focusing on developing rapid response capabilities for infectious diseases. Canada is prioritizing the development of a national vaccine strategy and increasing investment in research related to pathogen surveillance and response. Japan is focusing on improving laboratory safety protocols and investing in vaccine development to enhance its preparedness for future pandemics. Germany is increasing its investment in biotechnology research, particularly in medical applications and vaccine development, while also enhancing collaboration with EU partners. France is promoting public-private partnerships to accelerate biotech innovation, particularly in the fields of vaccine development and pathogen detection. India is emphasizing the importance of strengthening its public health systems and investing in biotechnology to improve its response capabilities for future pandemics. Differences in biodefense strategy focus. The varying responses to the lab leak theory across countries highlight differing priorities and approaches in biodefense strategies. While some nations focus on immediate research and development, others emphasize international collaboration and transparency. This divergence can be attributed to various factors, including political considerations, existing public health infrastructure, and historical experiences with pandemics. Expert predictions on biotech investments by 2026. As countries adjust their biodefense strategies in response to the lab leak discourse, experts predict significant shifts in biotech investments by 2026. Key predictions include: 1. Increased funding for biodefense. Governments are expected to significantly boost funding for biodefense initiatives focusing on vaccine development, pathogen surveillance, and laboratory safety. 2. Acceleration of vaccine research and production. The urgency of pandemic preparedness will lead to increased investments in vaccine research with a focus on developing rapid response capabilities. 3. International collaborations. There will likely be a rise in international collaborations aimed at enhancing global health security and improving response times to emerging infectious diseases. 4. Innovation in biotechnology. The competitive landscape of biotechnology will foster innovation, leading to advancements in areas such as bioinformatics and precision medicine. 5. Market expansion. The biotech sector is expected to expand with increased interest from investors looking to capitalize on the heightened focus on health security and pandemic preparedness. Conclusion. The global response to the lab leak theory has catalyzed a reevaluation of biodefense strategies across various countries. As nations adjust their approaches in light of new intelligence assessments and evolving scientific understanding, the biotechnology sector is set for significant shifts in investment and innovation. By 2026, increased funding for biodefense, accelerated vaccine research, and enhanced international collaboration are expected to reshape the competitive landscape of the biotech industry, reflecting lessons learned from the COVID-19 pandemic. The examination of the global response to the lab leak theory and its subsequent influence on biodefense strategies and biotech investments reveals several counterintuitive insights that challenge conventional wisdom regarding pandemic origins and the dynamics of biotechnology innovation. Counterintuitive insights. 1. Shift from natural to lab origins. The lab leak theory, once dismissed by many in the scientific community, is gaining traction among intelligence agencies such as the CIA and FBI. This shift is counterintuitive as it contradicts the long-standing narrative that zoonotic transmission is the primary cause of pandemics. The growing credibility of the lab leak theory suggests that the scientific and political communities may need to reconsider their previous assumptions about virus origins and the effectiveness of their response strategies. 2. Low confidence in assessments. Despite the CIA and FBI's endorsements of the lab leak theory, they both express low confidence in their findings due to insufficient evidence. This counterintuitive situation highlights a paradox where a theory gaining popularity is still underpinned by weak empirical support. It complicates the narrative and presents a challenge in formulating coherent public health and policy responses. 3. Impact on biodefense strategy. The response from countries regarding biodefense strategies appears to be more reactive than proactive. While one might expect countries to immediately overhaul their systems based on the lab leak theory's implications, many are instead incrementally adjusting their strategies, emphasizing existing frameworks rather than creating entirely new ones. This suggests a reluctance to fully embrace significant change despite the perceived risks. For the biotech patent landscape, the competitive landscape of biotech patents shows that while the U.S. leads in patent filings, the distribution of patents across different countries highlights a surprising uniformity in biotechnological focus areas. The strong similarities in the types of biotechnologies being patented, e.g., white, red, and green biotech across major players like the US, EU, and China, imply that competition may not be as differentiated as previously thought. This challenges the notion that national strategies are uniquely tailored, suggesting a convergence in innovation priorities. 5. Geopolitical dynamics and collaboration. The expectation that countries will engage in fierce competition for biotech dominance overlooks the potential for increased international collaboration driven by shared threats. The urgency of pandemic preparedness and the lab leak theory's implications may foster unexpected partnerships among nations rather than isolationist strategies, countering the prevalent narrative of nationalistic approaches to biotech investments. 6. Investment patterns. Predictions around biotech investments suggest a surge in funding directed toward biodefense and vaccine development. However, the historical tendency of biotech investments to be heavily influenced by immediate returns may not align with the long-term nature of biodefense preparedness. This presents a counterintuitive scenario where the urgency of the moment may lead to underinvestment in foundational research that does not yield quick results despite the obvious need highlighted by the pandemic. 7. Public perception versus scientific consensus. There is a notable dissonance between public perception and the scientific consensus regarding pandemic origins and responses. While the lab leak theory garners significant media attention and public debate, many scientists remain cautious and hesitant to fully endorse this theory, indicating a gap between popular discourse and scientific rigor. This counterintuitive divide complicates efforts to enact policy changes and secure funding for necessary research and safety improvements. 8. Market dynamics. The anticipated shifts in biotech investments may not solely be a reaction to the lab leak theory but also a reflection of broader market dynamics, including the increasing privatization of health technologies and the role of venture capital. This suggests that the narrative surrounding biodefense may be overly simplistic, failing to account for the complex motivations driving investment decisions that are influenced by more than just public health threats. 9. Regulatory frameworks. The response to the lab leak theory could lead to more stringent regulatory frameworks around laboratory safety and pathogen research. However, the speed and effectiveness of such regulatory changes could be hampered by bureaucratic inertia and competing interests, which contradicts the expectation that immediate action will be taken in light of new intelligence. 10. Global health security versus national interests. The dialogue surrounding biodefense strategies often emphasizes national security and self-interest, potentially undermining global health security initiatives. The tension between a nation's desire to protect its own interests and the need for collaborative global health responses may lead to a counterproductive scenario where countries prioritize short-term security over long-term global health stability. These counterintuitive insights highlight the complexities of the current landscape regarding the lab leak theory, biodefense strategies, and biotech investments. As nations grapple with these issues, the interplay between scientific evidence, public perception, and geopolitical considerations will likely shape the future of global health responses in ways that may not align with initial expectations or historical patterns. In examining the global response to the lab leak theory and its implications for biodefense strategies and biotech investments, several critical aspects may be overlooked by the general public but are significant in understanding the broader context of biotechnology and global health security. 1. The shift in intelligence assessments. One of the most important yet often overlooked points is the shift in intelligence assessments regarding the origins of COVID-19. The CIA and FBI stance that a lab leak is a plausible origin of the pandemic signifies not just a change in narrative but a potential shift in how governments approach biosecurity. The significance lies in the implications for international relations and public health policy. As intelligence agencies like the CIA express a low confidence in their assessments, it underscores the challenges of drawing conclusions from incomplete data. This is crucial for understanding how subsequent policies could be influenced by political motivations rather than purely scientific evidence. Many may dismiss the lab leak theory as fringe speculation, but its growing acceptance among intelligence communities indicates a need for serious consideration of biosafety and biosecurity measures in laboratories globally. 2. Biodefense strategy reevaluation. Countries are not merely reacting to a theory but are actively reevaluating their biodefense strategies. This response is significant because it indicates a collective acknowledgement of vulnerabilities in national health security systems. While discussions around enhancing laboratory safety protocols and increasing funding for research are common, the nuanced understanding that biodefense strategies must adapt to include not only responses to natural outbreaks but also potential lab accidents and bioweapon threats is crucial. This dual focus on both natural and anthropogenic risks may lead to a more resilient global health infrastructure. The public may overlook how shifts in biodefense strategies could lead not only to improved public health outcomes but also to the development of international regulations and standards for laboratory safety, which are vital in preventing future pandemics. 3. Impact on biotech patents and innovation. The competitive landscape of biotechnology patents is another area of significant importance that may not receive adequate attention. The U.S. leads in biotech patents with a notable focus on industrial and medical applications. The fact that over 96% of biotech patents pertain to these applications reflects the immense potential for innovation in responding to global health threats. The trajectory of biotech patenting can indicate where investment priorities lie, which is crucial for understanding future market shifts. As countries adjust their biodefense strategies, those that prioritize biotech innovation may gain competitive advantages in global markets. The public might overlook how these patent dynamics can shape access to medical technologies, influence drug prices, and impact global health equity. 4. Predictions for biotech investments by 2026. Expert predictions about biotech investments by 2026 highlight a transformative period for the sector. As countries channel investments towards enhancing biodefense infrastructure and accelerating vaccine research, the implications for the biotech industry are profound. However, the public may not fully grasp that these shifts may also lead to a reallocation of funding from traditional healthcare investments towards more strategic biodefense initiatives. This could result in a landscape where investment is heavily skewed towards technologies that promise rapid responses to pandemics or biosecurity threats, potentially neglecting other critical areas of healthcare innovation such as chronic disease management or mental health. The significance of this is that it could shape health systems around reactive rather than proactive strategies, which may have long-term consequences for overall health outcomes. 5. The geopolitical dimensions. The geopolitical implications of the lab leak theory and subsequent actions by countries to bolster their biodefense capabilities are often minimized in public discourse. As countries like the US and China grapple with the ramifications of the pandemic's origins, the potential for increased tensions and competition over biotechnological supremacy is significant. This competition could catalyze a biotech arms race where nations strive to outpace each other in innovation and patent filings, which could result in a fragmented global approach to health security. The overlooked aspect here is how this geopolitical competition might lead to silos of knowledge and technology that could hinder global collaborative efforts in pandemic preparedness and response. The public may not realize that the path countries take in this competitive landscape could dictate the future of international health cooperation. 6. The role of public perception and misinformation. Finally, the role of public perception and misinformation in shaping responses to the lab leak theory and biodefense strategies cannot be understated. As narratives around the origins of COVID-19 evolve, public understanding is often influenced by media portrayals, political rhetoric, and social media discourse. Misunderstandings or sensationalized accounts can lead to public panic or misplaced trust in certain technologies, ultimately affecting policy decisions. The significance of public perception lies in its ability to influence funding allocations, regulatory frameworks, and even the speed of technological adoption in health systems. The public may overlook that their views can have a profound impact on the scientific community's ability to pursue certain directions in research and innovation. Conclusion. In summary, while the examination of the global response to the lab leak theory and its implications for biodefense strategies and biotech investments covers many familiar themes, several critical elements deserve greater attention. The shifting intelligence assessments, the reevaluation of biodefense strategies, the competitive landscape of biotech patents, expert predictions about future investments, geopolitical dimensions, and the role of public perception all intertwine to create a complex and evolving narrative. It is essential for stakeholders, including policymakers, researchers, and the public, to engage with these nuances to foster a comprehensive understanding of how to effectively prepare for and respond to global health threats in the future. 1. Emergence of the lab leak theory as a credible hypothesis. The lab leak theory's increasing acceptance among intelligence agencies, notably the CIA and FBI, marks a significant shift in the narrative surrounding the origins of COVID-19. This perspective suggests that the origins of the pandemic are more likely linked to a laboratory incident rather than zoonotic transmission. This change not only reflects evolving scientific assessments but also has broader implications for national security and public health policies. The acknowledgement of the lab leak theory as a serious consideration by intelligence agencies underscores the necessity for improved biosecurity measures and responsible scientific practices, raising questions about the transparency of laboratory operations and the geopolitical tensions surrounding these investigations. 2. Impact on biodefense strategies. In response to the lab leak theory, countries are reassessing and reformulating their biodefense strategies. This involves enhancing research funding, improving laboratory safety, and investing in biotechnology to mitigate risks from potential pandemics or bioweapons. The emphasis on vaccine development, pathogen surveillance, and bioinformatics signifies a proactive approach to public health threats. Countries are likely to prioritize international collaborations and information sharing to bolster global health security, reflecting a shift from reactive to preventive strategies in biodefense. This transformation highlights the interconnectedness of global health and security, necessitating a comprehensive approach to biodefense that considers both natural and man-made threats. 3. Biotechnology, patent landscape, and innovation. The competitive nature of the global biotechnology sector is evident in the patent landscape, where the United States leads in biotech patents, followed by the EU and China. The concentration of patents in industrial and medical applications emphasizes the critical role of innovation in addressing public health challenges and enhancing biodefense capabilities. The data indicates that a large portion of biotech patents pertains to areas such as microbial engineering and diagnostic processes, reflecting ongoing advancements in technology that can significantly impact vaccine development and disease detection. Understanding the dynamics of biotech patents provides insights into the competitive strategies of nations and the opportunities for investment in emerging biotechnologies, particularly in response to lessons learned from the COVID-19 pandemic. 4. Predictions for biotech investment trends. By 2026, experts predict a substantial shift in biotech investments by 2026, largely influenced by the ongoing discourse surrounding the lab leak theory. Investments are expected to focus on strengthening biodefense infrastructure, accelerating vaccine research, and enhancing production capabilities. Additionally, There will likely be an increase in funding for international collaborations aimed at improving global health security. This anticipated shift in investment patterns underscores the importance of strategic foresight in the biotech sector, encouraging stakeholders to align their research and development efforts with emerging threats and global health priorities. As nations recalibrate their biodefense strategies, the biotech sector may experience a surge in innovation and funding, positioning it as a crucial player in the future of public health. 1. The 1979 Sverdlovsk anthrax leak. In April 1979, a deadly anthrax outbreak occurred in Sverdlovsk, now Ekaterinburg, Russia, which was later attributed to a leak from a military microbiology facility. The Soviet Union initially denied any connection to the outbreak, attributing it to contaminated meat. However, investigations revealed that a mishap during the production of anthrax spores led to the accidental release of the bacteria into the surrounding area, resulting in over 60 deaths. This incident highlighted the risks associated with biological research and prompted a reevaluation of safety protocols in laboratories worldwide. 2. The 2001 anthrax attacks in the United States. Following the September 11 terrorist attacks, letters containing anthrax spores were mailed to several media outlets and government officials, leading to 5 deaths and 17 infections. The event raised significant concerns about biosecurity and biodefense in the U.S., prompting an overhaul of policies related to biological threats. The investigation into the source of the anthrax revealed both lab-related origins and the necessity for improved surveillance and rapid response strategies in the face of bioterrorism. 3. The 2014 Ebola outbreak in West Africa. The Ebola virus outbreak that began in Guinea in December 2013 and spread to Liberia and Sierra Leone resulted in over 11,000 deaths. The global response to the outbreak was initially criticized for being slow and inadequate. The outbreak underscored the need for better preparedness and rapid response mechanisms to infectious disease outbreaks, leading to changes in global health policies and increased investment in vaccine research and biodefense strategies. The failure to contain the outbreak highlighted the vulnerabilities within public health systems and the necessity for improved international collaboration in health security. Future outlook: global response to lab leak theory and biodefense strategies by 2024. As the global community navigates the ongoing implications of the lab leak theory regarding the origins of COVID-19, significant shifts in biodefense strategies and investments in biotechnology are anticipated by 2026. This forecast is informed by the evolving assessments of intelligence agencies and the competitive landscape of biotechnology innovation across nations. Key predictions for biodefense strategies by 2024. 1. Increased funding for research and development. Countries are likely to ramp up funding for R&D in biodefense. This will include investments in vaccine development, pathogen surveillance technologies, and bioinformatics. Governments are expected to establish dedicated funding streams to support innovative projects aimed at enhancing public health resilience against future pandemics. 2. Strengthen laboratory safety protocols. In light of concerns raised by the lab leak theory, countries will likely enhance laboratory safety regulations. This may include stricter oversight of laboratories working with high-risk pathogens, improved training for personnel, and investment in advanced safety technologies. 3. International collaboration and regulatory frameworks. Nations are predicted to collaborate more closely on biodefense strategies, sharing best practices and intelligence regarding biothreats. This may lead to the establishment of new international regulatory frameworks to monitor and manage research involving potentially dangerous pathogens, similar to existing treaties on chemical and biological weapons. For a focus on sustainable biodefense, the biodefense strategies will increasingly incorporate sustainable practices, prioritizing environmentally friendly technologies and approaches that minimize ecological disruption while addressing biosecurity threats. Predictions for biotech investments by 2026. 1. Surge in biotech investments. the biotechnology sector is expected to see a substantial increase in investments, particularly in areas related to vaccine development and infectious disease diagnostics. Investors are likely to prioritize biotech firms that demonstrate innovative solutions for rapid response to health crises. 2. Emergence of new market leaders. As countries prioritize their biotech sectors, new market leaders are expected to emerge, particularly in regions like Asia. China's rapid advancement in biotech innovation could position it as a formidable competitor to the US and EU, especially in vaccine production and genomic research. 3. Diversification of investment portfolios. Investors may diversify their portfolios to include a broader range of biotech applications such as agricultural biotech and industrial biotechnology. This diversification will be driven by a growing recognition of the interconnectedness between public health, food security, and environmental sustainability. For a greater emphasis on bioinformatics, the market will witness an increased emphasis on bioinformatics and data analytics tools that enhance the understanding of pathogens and their interactions with human hosts. Companies specializing in AI-driven solutions for genomics and epidemiology are likely to attract significant interest. 5. Regulatory and ethical considerations. As biotech investments grow, regulatory and ethical considerations will become more prominent. Companies will need to navigate complex regulatory landscapes while addressing public concerns about bioethics related to genetic engineering and synthetic biology. Conclusion. The ongoing discourse surrounding the lab leak theory is reshaping the global approach to biodefense and biotechnology investments. By 2024, countries are expected to adopt more robust biodefense strategies characterized by increased funding, improved safety protocols, and greater international collaboration. The biotech sector is poised for significant growth by 2026, driven by innovation and the urgent need to address emerging health threats. As nations adapt to these evolving realities, the competitive landscape of biotechnology will become increasingly dynamic, with implications for global health security and economic development.